Hey guys, we are going to work on practice sheet number 9 for 8th grade. Number 1, good problem. This is an example of a star problem that they have used in the past. So, triangle JKL is dilated with the origin as the center of dilation to create triangle J prime, K prime, L prime. Okay, so dilation, remember that. This is the original. Okay, that's the original. So I want you to think if it's a dilation, which means there is a change in size, and notice what's happening to the size. What here could I get rid of? Which ones of these for sure would not work for a dilation? So what can you cross out? Hopefully you know you can cross out A and B because these are translations, okay? If it's a dilation, there's a number in front of the X, a number in front of the Y. It should be the same, okay? Now, another thing is that the shape is getting bigger. This is a scale factor of half, which means it's getting smaller, so that's wrong. So there's only one that would work, which is D. Now, the problem is, what if there was more than one that would work? We need to make sure we know how to do that. So what I would do is choose 1 point. I'm going to choose L because I know I can see that one. Okay, so here's L. That's the original. I'm going to label it because that's important. L is 8. 1, 2, 3, 4. 8 and 4 down. Okay. Now, for the new L, or the image, that looks like that's 14 over and 7 down. 14 and 7. So, if you remember, what goes in front of the letter here is this scale factor. So I have to find the scale factor. How do I find scale factor? New over original. So I need a new number over an original number. So the new number here for X is 14. And I'm going to do that also X, but for the original. That's the original. If you simplify this, you can just punch it into the calculator, 14 over 8, but you should get 7 over 4. These both divide by 2. Half of 14, half of 8 is 7/4. Notice that's what we got here. Even if you put in, well, I also didn't put the negative here, like I should have, because that was down. I would have new, that's the Y value, over the original. If I punch that into the calculator, you're going to notice that the signs disappear because a negative divided by a negative is a positive. Okay, so on this paper or on a separate sheet, I want you to write down those rotation rules. So I want you to pause the video and write down the rotation rules. If you're forgetting, remember it starts like this. Okay, so try to do that really quickly. So hopefully you did this. It goes turns 90, turns another 90, turns another 90. Then starts 0 plus 90 is 90. 90 plus 90 is 180. 180 plus 90 is 270. Okay. Remember the way I taught you is I always put 180 in first. I just think of it as the opposite. Okay. It faces the opposite direction and it's in that opposite quadrant. Okay, then yx, I do that first, and then I put x negative first and y negative second, okay? So on our problem that we're going to do, we're going to be doing this one, 270. So we do this rule, okay? So we're going to do one together, you'll do one alone. We're going to do U, 0.21. Get that new point first. Okay, then, remember we do this, flip it, 1, 2, the first one here should be negative, which is -1, 2. So now you're going to do V, okay? Okay, number 3, find the circumference. You're going to do this alone. You know that this is the radius, right? We've got to make sure we identify that. Please, 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 make sure every time you have that identified. Most of the time later, we're going to be using the radius. In this case, we already have it, so we're good. Okay, number 4 says dilate triangle PQR by a scale factor of 0.5. Okay, this is a decimal. I know normally we use fractions, but hey, we have a decimal on this one. Hopefully you know 0.5 is the same as 1/2. So I made a mistake here. I'm going to fix this before I reprint it. This is going to be U. That's where we're going to start with U. Okay, so U, I'm going to put my point for U, which is right there. 1, 2, 3, 4, 1, 2. It's down 2, that's why it's negative. Now, to put the new one, I just multiply. I'm going to multiply this number by 0.5. That will give me the new one here. Multiply this one by 0.5. That's going to give me the second number. Okay? So punch this into the calculator. 4 times 0.5. And you should get 2. Now multiply -2 times 0.5. And you should get -1. Okay? So now you try with this. Okay, number 5. This is a new one for us. Write the rule that performs the transformation from triangle ABJ to triangle A prime, V prime, J prime. I always wonder why they do these random letters instead of putting them in order. Okay, so what we need to do is, again, we're trying to figure out the rule. This is an example of a rule. Okay, y'all know if it's a translation, you'll see a plus or a minus. If you see sometimes the negatives in front of the y or the x, or you see the y's changed in order, you know that's probably some kind of rotation. Okay, so what I would do is, let's look at this. Notice this is not, these are not two congruent shapes. Okay, these are not two congruent shapes, so this has to be a dilation. Okay, so we're going to choose a point and figure out how it changes. So I'm going to choose point J. So here's the original. It looks like that's -1, -1. Okay, now I need the new one. This is original. Now I need new. Pre-image, image. Okay. 1, 2, 3, 4 backwards. 1, 2, 3, 4 down, so that's a negative. Okay. So one thing we know about a dilation is that if it gets larger, you have a scale factor greater than 1. If it gets smaller, you have a scale factor less than 1. More than 0, but less than 1. Okay, so we can tell from here to here, this is an enlargement. So we should have a scale factor greater than 1 if we're enlarging this. I'm just going to put enlarge. Okay. Scale factor, new over original. Does that sound familiar? New over original. And like we did in the other problem, I'm going to choose this. It doesn't matter because it happens to be the same. I'm going to choose my x value. Okay, the new one is -4. The original one is -1. Image, pre-image. And if you punch that into the calculator, you should get 4. I would do the y value, but it's going to be the same, the y coordinate. So that means my scale factor is 4, which means all this work, which just means always fun when those bells go off while I'm doing a video. Okay, which means this is the rule. Each of the coordinates changes by times 4. Okay, remember that means the perimeter gets 4 times bigger. The perimeter gets 4 times bigger, and the area gets 4 squared times bigger. Okay, just so you know, 4 squared, which is just kind of a side note, which is 16. That means officially 16 of these could fit inside of here. You could kind of manipulate them and they would fit inside of there. Okay? Okay, so getting close to the end. The perimeter of a rectangle is 32. The area of the same rectangle is 63 inches squared. If the sides of the rectangle are dilated by a scale factor of 2, what are the new perimeter and new area of the rectangle? Okay, so perimeter was 32, area was 63. I dilate it by a scale factor of 2, and I want to get my new perimeter and new area. So remember, perimeter changes by the scale factor. So that means I multiply that by 2. 32 times 2. That's going to give me my new perimeter. But area does not change by scale factor. It changes by scale factor squared. So it would be changing by 2 squared. So punch that into the calculator and you'll get the new area. Okay? And now we're going to do number 7. It says translate rectangle ABCD, x plus 4, y plus 4. Hopefully you know this is a translation. I didn't have to say translate. I could have just said transform. Okay? Or complete the transformation. So we're going to change A and D. So I'm going to do A. You're going to do the other one. Okay. So as you know, there's a couple ways you can do this. What I would do generally, just because I'm a visual person, is I move it on the graph. So I'm going to move x5 and y4. Okay, so x5, 1, 2, 3, 4, 5. y4, 1, 2, 3. Oops, it's off the graph, right? That's okay. So now I need to count that. I need to count that from the origin. So notice I don't go either way. I stay here. There's no left and right movement, so that's a 0. Then I count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 11. Now, if you are uncomfortable with not seeing it on the graph, you can also do this. You can say, okay, the original A, that's the original A. It is -5, 7. And then you would just need to do this. X would be +5. Y would be +4. So -5 plus 5, if you punch that into your calculator, is 0. Backwards 5, forwards 5, or down 5, up 5 gets you to 0. 7 plus 4 is 11. That's what we have here. So now your job is to do point D. So I want y'all to do that one.